Hello. In this video, I'm going to show you guys how to set up from start to finish a development environment for interacting and programming automated trading systems in the Trader Workstation API. If you don't know what that is, it's written by Interactive Brokers, one of the biggest brokers in the entire world for stock trading. And I'm going to show you how to set up an environment to start coding into their Trader Workstation API here on a Linux system. By the way, if you're a developer and you're not using Linux, what are you doing? Get on Linux right now. Thank you. Because Linux rocks. So I'm on Debian 12 over here on this system. And I've already done all the work for you. So just follow along like you're going to the beach on a nice, beautiful day. And that's what I should be doing right now. Press the like button if this video helps you. And at any point during the video, if you find that it's helping you a lot. So the first thing we need to do is find the guide. And the guide is on GitHub. Let's go to github.com/guitarmadillo/code. That's the name of the repository, and there's a folder in here called TWS API Linux video. Let's select it, and let's go over to the guide.txt file. And in this file, well, there's a guide on how to do everything that I'm going to show you in this video. And in that repository, there's also some bash scripts that will help you to compile your own programs using two different compilers on Linux, GCC, which is the default, and CLang or Clang. So I'm going to follow this guide that somebody wrote. If the guide is really bad, then this video will not be public. So if you're watching this, it means that the guide was good. The point of this video is to help almost anyone get set up with a C++ development environment for interacting with the TWS API under a Debian-based Linux distribution. First step is open your computer. All right, good. If you can do that, you're on the right path. Next step is open the terminal. A terminal is a very useful tool in Linux. And what I said here is you should open 3 tabs in the terminal because the way I'm going to show you how to do the manual setup, it's very important. If you're just learning, if you're kind of still beginner intermediate on Linux, which I am, I think, it's important to learn how to do things the manual way before you start automating everything. Because when you're automating everything, you don't know how things are working, so you're less likely to know what you're doing, okay? So I'm gonna start by opening up a terminal. Now remember, if you're following along with this guide, you need some coffee because everything in IT requires coffee. If you know who I'm quoting there, write in the comments below. I will open up 3 different tabs on my terminal. So I'll just select new tab twice. The next thing is you need to set up a working directory for where you want to be coding in and where you want to bring the library in and all that. So I'm already in a directory in my home directory called dev. If you don't have this directory, you can create it. So let's say you're in your home directory, you just do make directory dev, but I'm not going to do that because I already have it. I will go into that directory instead. So I'll do cd dev. And now here I'm going to make another directory called TWS API. So I'll do make directory TWS API. And I will go into that directory. And you can see there's nothing in here. We just created it. So now what you need to do is you need to download this folder here on the GitHub repository to get all those files and the bash script and all that, including this text README file. So go ahead and grab this link right here, copy it to your clipboard, paste it into your terminal. And now you should have all the files. However, they're not going to be exactly ready in your working directory. You just need to move them a bit. So I'll just fix that up really quickly. So I will cd into that new directory. And you can see there's a folder inside of a folder. Again, I'm such a GitHub noob at this point, guys, but don't worry, we'll get through it. So I'll cd into the TWS folder again here, and you can see these are all the files. So what I'm going to do is move them 2 directories back. So I'm going to do the move command. And I will do all the files, and then I will do 2 directories back. Whoops, typos right there. And then I will go back 2 directories, and we should have all the files right there. Now I could remove that folder right there, which we don't need. Sudo remove -r TWS API _Linux video. Put in the sudo password just to remove the directory. And we have all the files except for the license file, which is an Apache license, but who cares about that, right? So I'm in my working directory now here, dev TWS API, and I am going to open up that guide.txt file using a nicer text editor, and that's called gvim. So let's do guide.txt. And here it is. So let's drag that to the right. This is the exact same text file I was just reading there on the GitHub repo. So the next thing it says is that the bash scripts attached that I gave you guys 4 batch files here. They will only work if you set up your directory in this way, or else you're gonna have to go in and change the paths in those bash files. Okay, so I'm just letting you know. The next thing you need to do in order for the TWS API to work is, of course, you need to download TWS, which is Interactive Brokers Trading Software. I have it up there, and I just opened it here on the computer. And we're going to use this here. We don't need to log in right now, but we're going to use this here as the video goes on. You do need that installed. You need an IB account. So if you don't have an account, go and get one right now. The other thing is that the example code we're going to compile here is not going to work unless you have the NASDAQ top of book real-time data, which I'm not even subscribed to. I'm going to go subscribe to that here during the video just to show you how it's done. And then there's a general comment here saying that I find that TWS runs even better on Debian than it does on Windows. Interesting. The next thing we need to do is install the Clang compiler, and other development teams that I follow also recommend that compiler. So you'll do sudo apt install Clang if you don't already have it. And I already have it. You can see Clang is already newest version. Okay, I'll clear the terminal for now. I prefer the Nala package manager, but whatever, just install Clang any which way you want. The next thing we'll do is just quickly test your compiler on your system to make sure it works. So I'll go ahead and grab this line right here to the clipboard, and I'm in the working directory. I will ls to see the files in the directory. There's a file here that I put in called testcompile.cpp. Just use it to test the compiler. If you don't know how to compile anything, this step is for you, my friends. So what you're going to do is copy and paste that compiler line that I put in there. So I'll just paste it into the terminal. The compiler line is already set to compile the source code that's in our directory. The file is named testcompile.cpp. So everything's ready right there. I'll just press enter and it's compiled. Now I'll do ls, and you can see there's a new file here called test. That's the program we just compiled. It's a test program. So I'll run that program by doing /test, and this is our test program. So we have just confirmed that the compiler works. And how many employees do we need? Clearly a lot. Thank you. So now we need to go to the next step, and we need to get the repository from Jan Boonen. And you should read first about why this implementation of the TWS C++ API is helpful. In short, it's because the original code for the TWS API, apparently it had problems where it would not pick up syntax errors in your code. What Jan Boonen has done with this repository is he has fixed that so it does in fact pick up syntax errors, which is obviously what it should do. So go ahead and read that README file first if you haven't already. Then change to your working directory. We're already there. We don't need to change. The next thing is type in this command into that terminal, which you're going to clone the TWS C++ API from Jan Boonen. You're going to clone his repository. So I'll do paste it into my command line, enter. And now if we look in our directory, we have a new folder, TWS API CPP. The next thing is that's a little annoying. You don't have to do this right now, but remember to do it later, is that there's some changes you need to make to some of the library source code in order to make automated trading work again, because something happened with a new API version where it didn't work. Okay, so now that you have it, we can start by building it. We need to build the library and build the program. And the good thing is that Jan Boonen has already included all the necessary files for doing that. However, I've done it my own way because I like to do things my own way. But if you actually go into the directory, you'll find that there's make files. I don't think there's any one proper way of doing things, and you guys can comment if you guys are some sort of experts. I'm going to give you guys two different build methods right now for building a TWS API program. The first method is building the library as a dynamic link library first, and then building the executable file, your program, afterwards. And your executable is going to rely on that DLL. And so you have to make sure you do not lose that DLL or change its directory or move it around on your system. It needs to stay exactly in the directory of where the executable is looking for it. The second method is going to be compiling the library and your project source code into what's called object code, and then linking those two pieces of object code together into your final executable. And that way your final program does not have to rely on any dynamic link libraries. Now, personally, I prefer the second method because you don't have to worry about any files being in any directories. And I also think that this method is fine for this library because the library has a very small footprint to begin with. I found that it's pretty much fine to compile them together rather than having it rely on the dynamic link library. I created batch files that take care of all of this for you. I'm just showing you how it's done because this is the manual way first. You should know how to do it manual. Drive a manual car first before driving automatic. Unfortunately, that's not how it works today. Everyone's automatic. My next car is going to be a manual car for sure. So on our first tab of our terminal, I'm going to cd, change the directory of where the library source code is. So I'll do that. And now I am in the directory of where the library source code is. You can see it's right there, TWS API L0.C++ or CPP. The next thing is here, there's just some instructions for how I set up the compiler line. Now that we're in the directory for where the library source code is, we're gonna build the library into a dynamic link library. And I have two different compilers for you here. You can do it with GCC if you want. That's the default compiler on Linux. Or you can use Clang, which is my preferred one. Either way, it's pretty much the same exact thing, except that on Clang, there's a warning message that it gives you that talks about 56 unhandled enumeration values. You can get rid of that if you add in this to your compiler line right there, but you don't have to do it. In fact, I don't recommend adding it in, but I added it into the bash file just so it doesn't give you that warning every time you build the library. So go ahead and grab the compiler line for building the library here. We're already in the source directory for the library, so I'll copy this to the clipboard. I'll paste it in, and we're building the library. You can see there's our warning of 56 enumeration values. And if I look in the directory, the library we built is not there. Where did it go? If you look carefully at the compiler line, I actually put it in the working directory. So I'll go back to my third terminal tab here and I'll ls the working directory, and you can see we now have a DLL file in here called TWS CPP Linux API.dll. So that's the DLL we just built right now. And if you want to see how big that file is, you can see right there, it's 312 kilobytes. Okay, so the next thing is we need to build the test program. Now the good thing is in the Jan Boonen repository, there's a number of source code test examples that you can build. You don't have to write your own code to get started. Just use those examples, build them just to make sure everything's working, and then you can adapt certain aspects of that code and then build your own programs. Okay, so the first thing is we need to go to the directory of where the test source code files are located. So I'm going to do that in my second terminal tab. So just to clear it up, the first tab of my terminal is in the directory of where the library source code is located. The second tab of the terminal, I'm going to be using it in the directory of where the project source code is located. The code you write that controls your program is going to be in this directory right here. And I'm going to CD into that directory right now, following the guide, of course. So now I'm in the directory. If I ls here, you can see these are all the examples that Jan Boonen has provided. Then in the third tab of my terminal, it's just the working directory of where we are, and I'll clear it out. So the next step is we have to build the test program. So I'll build it using Clang because that's my favorite compiler. And I'll copy the 4-line compiler line here into the terminal. And there's actually an error message that we get when we build this file. The reason for this is because it's using some sort of old C++, or it might be from the C language. It's a less common way of printing things out. So what I'm going to actually do is go into the file that I'm building. So I'll go into the file with vim. So I'll vim, because we're already in the directory. And I will go into the file which is called test.cpp, and I will find that line. I'll do /gets, and I'll find the exact line that's giving us a problem, and I'm just going to comment it out because really it's not so necessary for what we're doing here. And once that's done, I'll just exit this and save it. And now I will build it again, and you can see now it built it fine. So if we go back over to our working directory and I ls lh, you can see we now have a test program that's appeared there. Now don't get it confused with the first test program that we created. In fact, we can remove that one. I'll remove test, okay? And now at this point, we already built a test program here that works with the TWS API. Let's try and run it and see what happens. So I'll do period / T test. Let's do it, and you can see there we go, API version 9.71, client version, etc., and it's running. It says it could not connect to TWS because TWS is not even running on our system yet. So what do you guys say we turn on TWS and see if it actually works? Do you think we should do that before going on to the more advanced method of building? Either way, the batch files are going to handle everything for you. Let's go ahead and open TWS and see what happens right now. Remember to get more coffee if you ran out. Mine is already full. Alright guys, so I have TWS here on my system. It's running now here on my Debian 12 system. And I'm going to go up to subscribe to market data because I want to go and get the NASDAQ subscription so that this program actually works and shows you something. So it's going to open up a browser tab over here. Okay, so I'm in the market data subscription manager page here on my Interactive Brokers account, and I'm going to select configure. Then I'm going to go ahead and go to level 1 NBBO, and I'm going to go and find the NASDAQ level 1 data, network C, $1.50 a month. I'll select it right there, and I will continue, and then I will confirm it right there. Okay, the subscriptions have been confirmed, so now I can close this page. And now if I just go ahead and enter, say, Microsoft into the quote board, I actually have a real-time quote of Microsoft now, which is coming in here. So that's good. We now have real-time NASDAQ stock market data. So the next thing I will do is go up to File, Global Configuration here, and I'm just going to make sure the API settings are set correctly. The read-only API is disabled, which is good. It should be that way. The socket port is already set to the correct number, which is 7496. And there's another setting called Create API Message Log File, which is very important for debugging. Keep that checked. That's very good. Okay, and now what I'm going to do is go ahead and run the TWS API program and see what happens. So I'll just run it again, and looks like we have a connection. And there's our real-time data from Microsoft coming in right there, and you can see it matches what's going on the DOM on the left there. And what this program does is it connects, disconnects. It's like a debug type of program, but when it connects, it gets the market data for Microsoft. So there you go, you have market data farm connected, and then right away it starts to get real-time quotes for Microsoft. And then there was a message there that I might want to look at here regarding EC Rec historical data. Warning, you submitted a request with date-time attributes without explicit time zones. So I'll end the program now in my command line. And I just want to show you how to get the API logs. So you go up to Help, Troubleshooting, Diagnostics, API logs. And you can see there's a file here that's been created. Let's select View Logs. So here's our API log. And if you ever run into a problem, or if you're trying to connect to a certain market data symbol and you're not getting it, normally the error is going to show up here. If it doesn't show up in your actual program itself, if you haven't configured it to debug properly, you'll see the errors come in here because these are the explicit messages provided by the TWS API. So definitely you need to look at this log file if you're trying to debug something. Okay, let's close it for now. Now I'm going to go ahead and show you guys the second method of building the TWS API program, which I think is a slightly better method. And your executable file size is going to be a little bit larger, but because everything is kind of lightweight to begin with, it's really nothing you should be worried about. Okay, so let's go ahead and do that right now. Let's scroll down to the next example here. In this building method, we're going to build the library and the program into object code or object files and then statically link them at compile time. This reduces the need for recompiling the library if changes were made and keeping track of where the library file is. Overall, it's simpler for the end user. So again, this is the manual method I'm showing you first, and then at the end I'm going to show you the quick method where everything is done for you in a batch file. So let's copy this right here, and we're going to go into the directory of the library source code in our first terminal tab. If you remember correctly, library directory, source directory, working directory. We're already in that directory, but in case you're not, just type in the cd command. We're already there. I'm going to build it with G++ for this example, but again, it doesn't really matter. I prefer Clang, but I just wrote G++ for this example right here. In the bash files, there's 4 bash files, 2 for GCC and 2 for Clang with method 1 and method 2, and you'll see what I mean. Okay, so I'll start by copying this to the clipboard, and what we're going to do now is we're building the library source code into an object file. You can see that GCC took a bit longer there. Let's ls, and you can see there's a new file here in this directory called TWS API L0.o. That's our new object file we just built. The next step is now we have to go to the directory of our test source code file. We're already there here in our second tab of our terminal, so we don't need to go there. And I'm going to compile the project source code or the test source code file into object code as well. So I'll go ahead and grab this compiler line, copy to the clipboard, go here, put it in. Let's wait for it to compile. It's done. Let's do ls to see our directory, and you can see we now have a file here called test.o. There's our object file. The next step is we need to go back to our working directory or whichever directory you want to output the file to, and then you need to build the executable using both object files. So I'll go ahead and copy this new compiler line here to the clipboard, and I'll go to our working directory, and let's build that. It's built. Let's ls, and we can see the file that I outputted here has a different name. It's called st_test because it stands for static, as in everything is statically linked. We don't need to worry about any dependencies or any DLLs. I can go ahead and delete that DLL. So I'll do remove TWS CPP, delete the DLL, and then I will run st_test. and you can see it's running. It's doing the same thing here. We connected to market data. It's running. So if you see this, you know it's working. So there's our second version of building it. Now I'll stop the program. Let's go on and show the use of the provided bash scripts for easy workflow. There's 4 different bash scripts here, and you can rename them to whatever you want. I just named them kind of to what I thought was okay, but they're labeled here as to which one does what. Okay, so in our working directory, remember we moved all the bash files here, so they have the extension .sh. And if you just want to look quickly at what these bash files are, let's go into TWS22.sh. So I'll do vim TWS22.sh just to look at what it is. And you can see this is a script that does everything I just showed you in the manual method, except it does it all for you just by running the script. And you can also, in this script itself, you can set some of the compiler parameters like the optimization level for if you're building a debug program for faster compiler time versus production code, which you would use the 2 or the 3 option in the optimization level. It's just as an example here, you can see I set up environment variables for the different paths and for the names of the different source files. And you would go ahead and change these if you're using a different directory or if your source file's named something else. And you can also change the output file name. In this example, this is using build method number 2 using the CLang compiler. So what this one is doing is it's starting by going to the library source code directory, building the library into object code, then going to the executable source code directory of where our project source code is, remember our program source code, going to that directory, building it into object code, then going back to our working directory or our target path directory, and then making the executable using both object files. And that's all. Then it runs it. You can comment this out if you don't want to run it every time. And that echo at the end here just adds a new line on your terminal, just in case you need to read things and not everything is on the same line. And let's run that. So let's do TWS22.sh. Let's run that bash file and see what it does. We got a permission denied error. That's something I wasn't expecting. So to check the permissions of these bash files, let's go ahead and do ls.lh in the current directory. And I believe that the reason why we're not able to execute the bash files this way is because they're not set to be executable. And I think you may have to do that yourself. So let's just do it as an example. In Linux, we're going to use this command called chmod, and we'll do +x, and then we'll type in the name of the file, tws22.sh. And now let's try and run it. And there we go, it run it, right? So you just had to make the bash files executable. And I feel like that's a good step to know anyways, because when you're writing bash scripts and you want to execute them quickly like that, you need to make them executable. They're not executable by default. So this is the program that has just been compiled and just been run at the same time. Now if I stop the program and then I look in our directory again, there's the program we just made using the bash file, bash_st_test. That's pretty much all there is. Now, if you want to get even more fancy, I would recommend setting up what's called a tmux session. Tmux is a terminal multiplexer. It allows you to turn your terminal into multiple terminals and then use keyboard shortcuts to move around them. However, you can already have this functionality in some Linux terminals. Like in this one, I have multiple tabs already, so you might not need tmux, but I use tmux on a remote server for this type of behavior where you compile the thing in one tab, you run the thing in the other tab, and you're coding in another tab. You know what I mean? So you use tmux for that type of workflow. And that's pretty much it, guys. Thank you for watching. I really hope this helped you get started building programs using this library. If you have any questions at all, please submit them down below in the comment section, and I'm happy to answer them. I'll answer them personally when I have time. Thank you for watching, and feel free to check out this tutorial right here, where I went over how to use some of the eWrapper functionalities in TWS API, although I was on Windows on this video. And if you want to see more videos like this, comment below. Thank you for watching. Cheers.